So the next question is, you need to calculate the retardation of a train during first 20 seconds. Please note that this is 0, 15, 20, 9, and the gradient is 9 minus 15, 20 minus 0, which is minus 6 upon 20. That is minus 0.3. But since it says retardation, the answer will be 0.3 meters per second square. The second part of the question is, show that the distance traveled during 90 seconds is 945 meters. So I will mark this A, this B, and this C. A is a trapezium, half into sum of parallel sides into height. B is 45 into 9, and C is once again half into sum of parallel sides into height, and the difference between 65 and 95 is 25. So the distance is half into 15 plus 9, that is 24, into 20, that is 240. 45 into 9 is 405, and half into 9 plus 15 is 24, into 25 is 300. So the total distance traveled is 300 plus 405 plus 240, which is 945, and that is what we wanted to prove. Calculate the average speed. Average speed is total distance upon total time. Average speed is total distance upon total time, which is 945 upon 90. That turns out to be 945 divided by 90 is 10.5 meters per second. Then the question says, if the train had not been held up and travelled the 945 meters at a constant speed of 15 meters per second, how much time would have been saved? So, part D, time is equal to distance upon speed. Distance is 945. If constant speed was there of 15, then the time taken would have been 945 divided by 15, which is 63 seconds. Currently it takes 90 seconds, otherwise it would have taken 63 seconds. So the time saved is 27 seconds. 90 minus 63 is 27 seconds. Agreed? The next question is, the diagram is a speed time graph of a car starting from rest. The car accelerated at a constant rate of 50 seconds, reaching a speed of 20 meters per second. The driver brakes sharply so that the car came to rest in a further 20 seconds. Calculate the acceleration of the car during first 50 seconds. So 0, 0, 50, 20. Gradient is 20 minus 0 upon 50 minus 0 is 20 divided by 50, 0.4 meters per second square. The second part of the question is to find the total distance traveled during the 70 seconds. So total distance is area under the curve, which is a triangle, half into base into height, that is 20. So the total distance traveled is 700 meters. Then the question says convert 20 meters per second into kilometers per hour, and I have explained you that to convert meters per second into kilometers per hour you have to divide by 1000 upon 3600. So the result is 20 divided by 1000 upon 3600. And it turns out to be 72 kilometers per hour. Sorry, meters. Yes, 72 kilometers per hour. 20 meters per second to kilometers per hour is 72 kilometers per hour. The next part, the next question is the diagram shows the speed time graph of a car which has a speed of v meters per second at a time of t seconds. You need to calculate the speed when time is 10 seconds. Please realize that time 10 is here. So we need this speed somewhere here. So first we need to find the gradient of the last part of the journey, that is 8,16, 12,36. The gradient is 36 minus 16 upon 12 minus 8, that is 20 upon 4, that is 5 meters per second square. So 8,16, 10, s will have the same gradient of 5 meters per second square. S minus 16, 10 minus 8 is 5, which is s minus 16 upon 2. S minus 16 is equal to 10. S is 26 meters per second. So this is 26 meters per second. I found the gradient of the last part, and then using that gradient I found the required speed. Then the question says the value of t, for which v is 13. 13 is somewhere here. I need to find the t. So once again I will do the same process. I will first find the gradient during the second part of the journey, 4,4, 8,16. The gradient turns out to be 16 minus 4, 8 minus 4, that is 12 upon 4, which is 3 meters per second. Using this gradient, 4,4, t, 13, and I know that the gradient is 3, so 13 minus 4, t minus 4 is 3. 13 minus 4 is 9, t minus 4, 13 minus 4 is 9 upon t minus 4 is 3. Let's cross multiply. 9 is 3 times of t minus 4. So t minus 4 is 3, t is equal to 7 seconds. Then the distance traveled in the first second. Please realize, if this is 4 and this is 4, this is 0. If this is 1, this will be 1. So half into 1 into 1 is 0.5 meters. Please realize this is 0, 0, this is 4, 4, obviously then 1, 1, and hence half into 1, 1 is the result. The next part of the question is that the diagram is the speed time graph for a particular journey. You are told to calculate the retardation during last 30 seconds. Last 20 seconds, I'm sorry. So this is 120, 24, 120, 24, and 140, 0. So the gradient is 0 minus 24, 140 minus 120, that is minus 24 upon 20, that is minus 1.2. But since we need to find the retardation, we'll write it as 1.2 meters per second square. The second part of the journey is to find the speed after 25 seconds. The speed after 25 seconds means that the first part is to find the gradient during the first part of the journey, 0, 0, 30, 24, 0, 0, 30, 24, and the gradient will be 24 minus 0 upon 30 minus 0, which is 3, 8 is 24, 3, 10 is 30, 0.8 meters per second square. Using this 0, 0, 25, s, and the gradient is 0.8, we can find s minus 0, 25 minus 0 is 0.8, hence s will be 0.8 multiplied by 25, that is 20 meters per second. Then the question is to find the total distance traveled. To find the total distance traveled, I can easily use the formula for area under the curve, that is area of trapezium. But if you look at part B, you need to draw the distance time graph. If you need to draw the distance time graph, my advice would be to break the journey into smaller parts. This is A, this is B, and this is C, and find the distance of each part individually. So distance of A is half into base into height, that is half into 30 into 24, that is 360 meters. The second part is a rectangle, 120 minus 30, this is 90. 90 into 24 is 2160, and the last part of the journey is a triangle, that is half into base. The base here will be 20 and height is 24. This is 240. So the total distance traveled is 2160 plus 360 plus 240, that is 2760 meters. And since we need to sketch the distance time graph, please realize that this is 360. When the speed of the particle is increasing speed, then this shows increasing speed. The straight line represents constant speed, and this represents decreasing speed on a distance time graph. So the first part has already been made for you, the increasing speed part. The second part is a straight line, 360 plus 2160. 360 plus 2160 is 2520. So this is 2520, and then comes the ending bit, that is the decreasing speed, which is 2760. So this is 2760. So the graph drawn is something like this. This is 0, this is 360, this is 2520, and this is 2760. I hope this is clear. Then question number 47 states that the diagram shows the speed time graph of first 20 seconds of a cyclist. Calculate the distance traveled in first 10 seconds. The distance traveled in the first 10 seconds is half into base into height. That is 40 meters. Then the total distance traveled in 20 seconds. So if I label this as A and this as B, I have found A. B is 20 minus 10 is 10 into 8, that is 80 meters, and the total distance is 120 meters. And part C is to draw it on the distance time graph. Please realize that the first part, this part is increasing speed and this is the constant speed. So the increasing speed will be like this and then constant speed is like this. I repeat, the increasing speed is a curve and constant speed is a straight line. Agreed? Then question number 48 states that the diagram shows the speed time graph for a runner in final 25 seconds of a cross country race. Calculate the distance he ran during first 10 seconds. So to find the distance during first 10 seconds is 10 into 6, that is 60 meters. Then the total distance he ran in 25 seconds. So if I label this as A and this as B, then A has been found. B is half into 25 and 10. The difference here, 25 and 10 is 15. Height is 6. 45 meters is B. Total distance is 105 meters. So the next part of the question is to draw the distance time graph for this final part. So please realize that during the first 10 seconds, it's constant speed and then it is decreasing speed. So as I mentioned earlier, this is increasing speed, this is constant speed, and this is decreasing speed. I have made it accordingly. Question 49. The diagram is the speed time graph of a journey. Calculate the retardation during last 20 seconds. So this will be 60, 30 and 80, 0. So the gradient will be 0 minus 30, 80 minus 60. That is minus 30 upon 20 minus 1.5 meters per second square. The total distance traveled, to find the total distance traveled, half into sum of parallel sides. 40 and 60 difference is 20. This is 80. Half into 20 into 80 into height, that is 30. Half into sum of parallel sides into height. This is 1500 meters. Half into 20 plus 80 is 100 into 30. 1500 meters. The distance time graph of 50 to 60 is a straight line. Calculate the distance time graph of 40 to 60 is a straight line. Calculate the gradient of this line. Please recall that the gradient of distance time graph is speed. So what is the speed? What is the speed during 40 and 60? The speed during 40 and 60 is 30. Since it is 30, then the result will also be 30 meters per second automatically, because the gradient of the distance time graph is speed time graph has been made for you. So if you need to find the gradient of distance time graph, the gradient of distance time graph is speed. So during 40 to 60, speed is 30, and hence the gradient of the distance time graph is 30 meters per second. If, let's suppose, you were told to draw the acceleration time graph. To draw the acceleration time graph from speed time graph, this will be acceleration, this will be time, and if I am making the acceleration time graph of this particular journey, then 40, 60, 80. I need to find the acceleration during first 40 seconds, acceleration during first 60 seconds, then next 20 seconds, and acceleration during next 20 seconds. So the acceleration of the first part of the journey is 0, 0, 40, 30, and the result is 1.33 meters per second square. The acceleration during second part of the journey is 0. It's a constant horizontal line, and the deceleration has already been found as minus 1.5. So 1.3, 0, and minus 1.5. So during the first 40 seconds, acceleration is 1.33. During next 20 seconds, acceleration is 0, and during last 20 seconds, acceleration is minus 1.5. So acceleration time graph is made in a manner that the gradient of each part of the journey is drawn as a straight line. So this marks the end of kinematics. I hope this is clear to all of you. You need to do the homework from your regular book that we use, the practice book, and I will be writing the homework as part of the comments of this video. So please make sure, after looking at this video and after doing all the needful conceptual revision, you do the homework that I will shortly be posting in the comments. Thank you. I hope you enjoyed kinematics. This is all from kinematics from O-level mathematics perspective. I will be discussing the problems of the homework inshallah in a day or two, and I will be updating you about that. Thank you. Allah Hafiz.